Manufacturers of disposable cleanroom garments advertise that their products are better than reusable garments because they have a higher bacterial filtration efficiency, or BFE. So what exactly is the BFE of a cleanroom garment? It's the percentage of bacteria that is able to pass through the fabric. Fabrics with higher BFEs allow less bacteria to pass through. Some manufacturers of disposable cleanroom garments will tell you that their product has a BFE of over 90%, while a reusable garment has a much lower BFE due to multiple launderings and sterilizations. They claim that these results were produced by a test method that we'll reenact in this video and prove to be flawed. In fact, if both fabrics were tested by this method, you would expect the BFE of the reusable garment to be near 100%. Let's look at the test method that produced these results. This is the reenactment of the test performed by a manufacturer of disposable cleanroom garments and posted on their website. It is Prudential's contention that, if the test was performed as shown, both the disposable and reusable garment fabrics would have very high BFEs. In a horizontal laminar flow hood, the lab technician places a piece of fabric over the top of a petri dish containing nutrient agar. He then fastens the fabric to the petri dish using a rubber band. The fabric sample does not touch the surface of the agar. Next, he sprays a small amount of liquid containing bacteria from a squirt bottle onto the fabric and lets the plate sit for 24 hours. Upon removing the fabric sample, the technician sees several bacterial colonies growing on the agar. Now let's take a look at some of the things that are wrong with this test method. First, the test is being performed in a horizontal laminar flow hood. If the hood is operating, the bacteria sprayed onto the fabric will be blown out of the hood and into the unprotected face of the technician. Much of the bacteria will blow away before even landing on the fabric. This would reduce the bacterial challenge to the fabric and artificially increase the BFE. If the hood is not operating, air currents from outside of the hood can blow the challenge bacteria away from the fabrics, thereby reducing the bacteria challenge and increasing the BFE. The second problem with this test is that it uses a pure culture of Staphylococcus bacteria suspended in a liquid to challenge the fabric. Some individual bacteria can enter the pores and pass through the fabric. However, most of the bacteria will occur in clusters, which are too large to pass through the fabric, artificially increasing the BFE. Also, in the real world, these bacteria get from one place to another by hitchhiking a ride on larger particles such as skin flakes. These skin flakes are not able to pass through the fabric. The third problem with this test method is that there is no vacuum or pressure applied to the fabric to help the bacteria pass through it. Even the small amount of liquid applied by spraying will be of no help after it has quickly evaporated. With no mechanical help, the bacteria will not pass through the fabric and the BFE will be higher. The final problem with the test method is that the petri dishes are not incubated. This would make it very unlikely that colonies would grow sufficiently in 24 hours, as shown in the reenactment. Prudential believes that the preferred test for evaluating the entire garment system is the particle dispersion test, also known as the body box test. This test measures the microbial barrier properties of the garment, not just the fabric. In addition to being a better overall barrier to microbial contamination, reusable cleanroom garments are also a better environmental choice. For more information about reusable cleanroom garments, contact your Prudential Cleanroom Service sales representative.